Welcome to lecture number 2 in section 4, and in this lecture we will be discussing why computer system needs hierarchy of memory. The CPU is the brain of the computer system where both arithmetic calculations and logical operations take place. The CPU is also alternately referred as processor or a central processor or a microprocessor. The CPU is the most important component in a computer system. A computer CPU handles all instructions it receives from hardware and the software running on the computer system. Before we dive into the topic of why computer system needs hierarchy of memory, it is important for us to understand the factors that affect the performance of the computer system. There are several factors that affect the CPU performance. Amongst the most important factors include the first factor is the CPU speed and the CPU type. The CPU speed is referred by gigahertz, which is a speed of the number of cycles it clocks per second. The CPU type includes the number of cores present inside the processor chip. The second factor is the size of the main memory RAM. This is a critically important factor. The most common size of the RAM is in the multiple of 4, that is 4 GB, 8 GB, 12 GB and 16 GB. The third factor that affects the performance is type of the operating system, whether it's a 32-bit system or 64-bit system, which indicates the size of the main memory supported by the operating system. The bit size of the central processing unit dictates the maximum permissible size of the main memory RAM. For example, a 32-bit CPU and 32-bit operating system, the maximum RAM supported is 4 GB, and for a 64-bit CPU and 64-bit operating system can support any size of the main memory RAM. In computer architecture, the CPU is responsible to process the data as per the program instructions. The CPU can execute program instructions at a very high speed, a gigahertz, which is the most common form of measure of processor speed, and it means that 1 billion clock cycles can be completed per second. The CPU can process the data at a very high speed. During the program execution, the CPU has to continuously fetch the data from the system memory. However, the permanent memory, which is also referred as a disk memory or a hard disk of the system, cannot transfer the data to the CPU to match the processing speed of the CPU. This slows down the processor speed, and therefore we need intermediate memory such as RAM or cache, where the data access speed is relatively much faster as compared to the disk memory. As you can see in this diagram, the computer system memory consists of 4 types of memories: disk memory, main memory RAM, cache memory, and CPU registers. The disk memory ranks the lowest in the memory hierarchy due to its lowest access speed. The registers rank the highest in the memory hierarchy due to its very high access speed. However, the CPU register size is restricted mainly due to cost considerations. Therefore, in computer architecture, in order to optimize on the CPU performance, different types of memories are placed between the CPU and the disk memory. These memories are placed in a hierarchical order depending upon the data access speed, size of the memory, and distance from the CPU. This arrangement significantly improves the system performance. That brings us to the end of lecture number 2 in section 4, and in this lecture we discuss how computer system makes use of different types of memory in a hierarchical order to optimize the system performance. Thanks, and I will see you soon for the next lecture.